All right. It's going to be a short one. We are going to take this same idea and apply it to volume. So we have very little to discuss because I'm guessing that possibly upwards of 80% of the people in this room can tell me the answer already without me ever saying anything. Okay? Here's the question. If corresponding sides of two similar solids. So now we're talking about three-dimensional objects, solid figures, not planar figures. If corresponding sides of two similar solids have a ratio of m to n, then their volumes, don't say it out loud, have a ratio of, don't say it out loud. This is the question that 80% of you probably know the answer to already.
M3.
Which, in other words, way of saying is 3, M3 is cubed over n cubed. Okay? So the same thing as yesterday. Yesterday we were doing area, and like I mentioned, area is square units. So if you know the ratio of the sides, you square it to get the ratio of the areas. Volume is in cubic units. If you know the ratio of the sides, then you cube it to get the ratio of the volume. All right? So I really haven't taught you anything. You already knew area was squared. We're just applying that in a different way. You already knew volume was cubed. We're just applying that in a different way. If you know the ratio of the volumes and you want to know the ratio of the sides, what do? Cube root. Okay? And then they can make things really super fun. So let's say the ratio of the volumes of two things is, what's a good, 27 to 8. And they ask you, what is the ratio of the areas? Okay, if the ratio of the volumes is 27 to 8, and they ask you what the ratio of the areas is, Anthony? Okay, 3 to 2. He said because if I start with 27 to 8, how did you get 3 to 2 out of that? How did you get the 3 to 2? Right, cube root both of them. Okay, so the cube root of 27 is, how do you do it? How'd you do it? On your calculator? Okay, so you can do it on your calculator. There's a root button that I can show you on there. The easiest way though probably to do cube roots, because they're going to give you easy numbers to work with, is just guess and check. 2 times 2 times 2 is what? 8. So that means the cube root of 8 must be 2. 3 times 3 times 3 is what?
27.
27. So that means the cube root of 27 is 3. And then 4 times 4 times 4 is 64. So the cube root of 64 is 4. And 5 times 5 times 5 is 125. So the cube, you know what I'm saying? So you can just kind of work your way backwards a little bit. Okay, so if I take the cube root of the two volumes, what does this ratio give me? The ratio of the what? Yeah, the ratio of the sides. Okay? But we want the ratio of the areas. So if I know the ratio of the sides, what do I do to get the ratio of the areas, Jacob?
Square to 9 over 4.
Right, square the 3 over 2 and get 9 over 4, which would be the ratio then of the areas, okay? So they can make your life difficult, and I'm sure they will, by making you bounce around between all 3 of these ideas, okay? So if you know the volumes, you cube root it, that gives you the sides. If you know the sides, you square it, that gives you the areas. If you know the areas, you can square root it and get the sides. Yeah, stressful, huh? And then if you want the volumes, you can take that and cube it. So you just have to keep all those relationships straight in your head, okay? But that's all I got. That's all I got. Is that all right, Zola? Is that okay?
Yeah.
Okay.
I mean, I guess.